So what formed first? Is it oceans or is it continents? See, to store water we require a container, right? Similar way, for the existence of oceans, there must be some solid base, right, with some depressions to hold water. Is that solid base is the continent? Which means, does continent formed before oceans? But the geological studies says that life began in the oceans. So this sounds more like $1 million question, which came first, chicken or egg? Let me know in the comments what you feel about this question. We may not have a unanimous decision for this question. But yes, we do have a proven theories to decide what comes first. Is it oceans or is it continents? So let's get into the video to solve this paradox. Like other planets, even Earth was formed by the accumulation of detached materials from the Sun, which was initially a hot gas nebula. So there's nothing like solid crust in the initial days. By initial days, I mean first few million years. So in geography, if we say that Himalayas are the recent formation, which means Himalayas have started forming 50 million years ago. So this is one of the reasons that we cannot observe the complete process of the formation of any landform. So coming back, Earth was a hot gaseous nebula and there's nothing like solid crust. This hot gaseous nebula has undergone two significant processes, that is degassing and density differentiation. The main difference between these two is degassing is an external process which takes place while interacting with the atmosphere. On the other hand, density differentiation is an internal process which takes place within Earth's interior. However, these two processes perform its functions simultaneously. That is, when degassing is taking place externally, density differentiation performs its functions internally, that is within the Earth. Degassing is the ejection of hot gases such as carbon dioxide, nitrogen, and water vapor. As we know, under conduction, when we place hot and cool objects besides each other, the hot object transfers heat until both attain the same temperature. So in our case, outer atmosphere is a cool body and hot gas nebula is a hot body, and heat transfer is taking place by the ejection of hot gases. So this continuous degassing leads to cooling and solidification of uppermost layer, resulting in the formation of primitive crust. The deformation of the primitive crust under the influence of density differentiation results in the formation of oceanic crust. So let us know about the formation of oceanic crust out of the primitive crust. I'll do a separate video explaining the convectional currents and the tectonic plates, but for time being, consider the convectional currents as a upwelling hot molten material which gets dispersed below the Earth's surface. After that, the currents move in opposite direction, which gets cooled and sink down back towards the Earth's interior. This process entirely is called convectional current. Using this convectional currents, the denser and the heavy material like iron and nickel settles down at the greater depths of the Earth, whereas the lighter material like silica ascends towards the Earth's surface. This adjustment of material based on the density is called density differentiation. Here is the primitive crust and the upwelling convectional current which is moving from the Earth's interior towards the primitive crust. The hot molten material after reaching the Earth's surface as a part of convectional current melts the primitive crust, which leads to crustal thinning. Further pulling of crust on either sides by convectional current causes crustal breakage. This breakage provides a way out for the hot molten material, which later cools and solidifies, forming the oceanic crust. So this is how oceanic crust forms at the cost of primitive crust. This figure provides us entire process in the single frame. On one hand, there is a formation of oceanic crust. On the other hand, there is a destruction of primitive crust. So this is how ocean crust is expanding at the cost of primitive crust. This is how the flow of the process looks like. Now a solid base to store water, which is oceanic crust, is ready. Let's see how does it got filled by water to form oceans. We already had a discussion about degassing, which is ejection of hot gas, among which one of the prominent gas is water vapor. As temperature of atmosphere reduces with altitude, thereon it loses capacity to hold water vapor. This leads to condensation of vapor into droplets, which appear in the form of clouds. And then, as we all know, precipitation begins. And finally, the oceans got formed. So this is how oceans were formed. So yes, we got the solution for the question that we had at the beginning of this video. This is the summary of the entire video where primitive crust was formed due to degassing and the ocean crust was formed due to density differentiation of the primitive crust. And this ocean crust acts as a base or the container of the oceans. And finally, deformation. Ocean crust leads to the formation of continental crust. So what got formed first? It's definitely oceans. Finally and obviously, subscribe to this channel to get more updates. Thank you.